Let's look at this question. 7 localities A through G in a city were connected by certain two-way and one-way roads as shown in the figure below. This morning, Kishore, the newly appointed traffic commissioner of the city, changed all existing two-way roads into one-way roads. So right now between B and A, you have a two-way road because it is joined by a double arrow. Between A and D, you have a two-way road. Between D and F, you have a two-way road. Between E and G, you have a two-way road. Between C and E, you have a two-way road. Between A and C, you have a two-way road. The only places where you have one-way road is D to B, F to E, and F to G. Okay. So all the two-way roads have been turned into one-way road, while ensuring that any locality can be reached from any other locality. Okay. Now, in order to implement this change, the places which are going to be interesting is going to be G, is going to be C. Look at it. And how I'm going to represent it is this way. See, from F to G, there is a one-way road. So, if you are able to visit that city, and you're able to visit any other city from that city as well, there must be a path out of G. So G to E will turn into a one-way road where the path is going from G to E. G to E. This arrow will no longer be applicable. Or let me remove it this way. This arrow is no longer there. Now, from F you can come to E. From G you can come to E. From E you should be able to get out. You should be able to get out only if this arrow is not there. E to C becomes a one-way road. Then to C, you can come to C from E, but you also need to get out of C. You can get out of C if you have one-way road from C to A. If you have one-way road from C to A. Now, to B, you have one-way road going here. Okay. Another thing, from F, you have a road going out. From F, you have a road going out. You also need to have a road coming into F. So D to F will be a one-way road. D to F will be a one-way road. Additionally, now from D to B, you have movement. From D to F, you have movement. You also need to have movement into D. So that will be from A to D. A to D. Now, to B, you are coming in order to go out. This should be the situation. B to A should be a one-way road. And now, hopefully, you can see all the two-way roads. All the two-way roads have been converted into one-way roads. All the two-way roads have been converted into one-way roads, and still you can visit any city from any city. Every city has the possibility that you can come to that city and you can get out of that city. The final state will look something like this. I've gone ahead and kept this diagram prepared beforehand. How do I place it? Wait. Let me get rid of all these markings first. And just place this on top of this. This is how the final state will look like. This is how the final state will look like. Wherein D to B, A to D, C to A, E to C, G to E, F to E, F to G, all of this. Although the question had given us a separate diagram, although the question has given us this diagram at the time of solving, in your solving, you will arrive at this diagram, and this is the diagram on which you are supposed to solve. Let's go through the individual questions. What is the minimum number of localities that a person must pass through to go from G to D? In order to get from G to D, the only way you get out of G is to E. So you go from G to E. Again, the only way you get out of E is go to C. The only way you get out of C is to A. And the only way you get out of A is D. So what is the minimum number of localities that a person must pass through to go from G to D, excluding G and D? These three localities you have to pass. Answer is 3. Next, in how many ways can a person travel from F to C without passing through any locality twice? F to C. Okay. I can see one path is FEC. From F, I can go to E, or from F, I can go to G. These are the only two places. Once I get to E, the only destination spot is C. That is the only place I can go to. If I go to G, the next spot has to be E. And then by default, the next spot has to be C. There are no other paths by which I can go from F to C. So in how many ways? There are two ways. These are the two available paths. Okay, next. Three persons started from one locality and reached another locality, and none of them visited the same locality more than once. If for each person there was at least one road that the other two did not travel on. This is another way of saying all of them took different paths. Which of the following can be the origin and destination of the three persons? Okay. In this case, all you have to do is go through options. So let's check options. From D to F. Sorry, from D to E. One way is D, F, E. This is a path. Another path is D, F, G, E. D, F, G, E. Another path is D. See, from D, I can go to F or I can go to B. These are the only two ways. If I go to F, either it is E directly or it is F, G, E. So that is done. So now I'm checking the other case, D, B. Then I have to go to A. And the only exit from A, the only way you exit from A is return to D again. But we were told you did not visit the same locality more than once. So I can't come back to D. I can't come back to D. And thereby my journey stops here. Which is to say, in order to get from D to E, there are only two separate paths available. So option 1 will not be the answer. Let us check B to E. If I'm going from B to E, the first path available is, see, B to A is definitely happening. Then from A to D is definitely happening. I can't go back to B, so B to F is definitely happening. From F to E, I can go. Another way I can go is F to G to E. But there are no other routes available apart from these two. So origin being B and destination being E, this will not work. This is not the correct option. Let us look at the next case. G to F. Okay. In order to move from G to F, I'm seeing G to E is a guaranteed move because that is the only exit from G. E to C is a guaranteed move, only exit. C to A is a guaranteed move, only exit. A to D is a guaranteed move. And then D to F. One path has been identified. The only spot where I had two options was when I reached D. But as soon as I go to D, let's say I take the path to B. I go G, E, C, A, D, B. Once I've reached B, I have to go back to A again, which would be revisiting an original city, which is also unacceptable. So this option also does not work. Option C also gets rejected. By elimination, you can say answer has to be option D. But for the sake of comprehensiveness, we will also look at the case. How does that work? If I have to go from D to A, the simplest path I see is D, B, A. Another path I see is D, F, D, F, E, C, A. Another path is D, F, G, E, C, A. Basically, F to E can have G included in between. So three different paths are there. I can move from D to A. There are three different paths. So answer will be option D. Okay. Next, if a person traveled from one locality to another and passed through all the localities exactly once, how many of the 7 localities can be the locality from which he started? So you have to start from any of these locations, from any of these localities, and you have to visit all 7 localities. Let's see if we can accomplish that. Let's say our starting point was, if our starting point was A, the only exit is to D. Now, if the only exit is to D, if I go to B, I will have to go back to A. So I will not go to B. Let me go to F. But if I go to F, can you see D city B cannot be visited anymore? City B cannot be visited anymore because the only way to get to city B or only way to get to locality B was via D. So locality B cannot be visited. I can straight away say A cannot be the origin city. Let's check if B is the origin city. If B is the origin city, I know A is the next city to go to. Then I know D is the next city to go to. Then I know F is the next city to go to. Now from F, I can go to E, I can go to G. I would prefer going to G because if I go to G, then E and then C, then my target is achieved. G, E, and C. All 7 cities have been visited. This is awesome. My life's goal, my target, everything has been achieved. So B is to be counted. Let's check C. If C was the origin city, if C was the origin city, I get to A. Once I get to A, I have to go to D. Once I get to D, the same problem that I had with DB and DF, DB and DF, the same problem has emerged again. If I go to F, B will not be visited. If I go to B, I will have to revisit A all over again, which is to say C cannot be the origin city. Let's have D as the origin city. If D is the origin city, if D is the origin city, if I go to B, the only entryway into B is via D. If I go to B, when I go to A, I have to come back to D. Not great. But if I go to F, I cannot visit city B at all. I cannot visit city B at all. I can perhaps visit everything else. I can go from D to F to G to E to C to A, but I cannot visit city B at all. So D also cannot be the origin city. Let us try with E. If E is the starting city, I go to C, I go to A, I go to D, and we are back at the same point. See, every time you reach a spot after D, that is when you get stuck. So if D is the starting, if you've arrived at D as a decision making point and you haven't visited B yet, or you haven't visited F yet, then it is a problem. So from D, I can either go to F or go to B. If I go to F, B will never be visited. If I go to B, I will have to return to D all over again. So E also cannot be the starting point. Let's try with F. Let's try with F. From F, I will go F, G, E or F, E, C. If I go F, E, C, G will never be visited. So F, G, E is the right move. From E, I can go to C. From C, I will have to go to A, I will have to go to D. And now, because F is already visited, I can go to B. So yes, this also works. And this also works. I have 2 acceptable cases so far. My origin city can be B or my origin city can be F. The last case to check is origin city of G. If I start with origin city of G, next city has to be E, then it has to be C, then it has to be A, then it has to be D, and then we are stuck again. If I go to F, I can't go to B. If I go to B, I will have to visit A again. So G also cannot be the origin city. The only 2 localities from which he can start and visit all the localities without visiting any locality twice are B and F, and therefore the answer to the last question is 2. And that is the entirety of this set. This comes under something known as network diagrams. Hopefully, we have practiced a lot of it.